Good morning, stat students. It is Halloween Eve, and I am cosplaying today as the greatest video game champion of all time, Dr. Disrespect. Got a test today. Okay. We took a practice test yesterday. We're going to look at the results of that practice test today, before you take your test, the real one, today as well. Okay. Once you're done, go straight into the grade book. Go ahead and get involved. So, here is the distribution from the practice test. It looks pretty good overall. The biggest missed question was number 2. Number 3 also was missed quite a bit, so we'll be talking about both of those. And then I had a special request to look at questions 9, 10, 11, and 12. So we're going to be looking at all of those today. So buckle in. Get ready to get involved. Let's start with number 2. Let's change the song. Better. Okay. So for a normal distribution shown, the standard deviation is closest to. Now, the understanding on this is that you need to first identify the mean, which is going to be 2. Or thereabout 2. And then the first deviation is going to be where the point of inflection is. Okay? The point of inflection. So it's coming down, 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 and it starts changing directions about right here. So that looks like 5, and that also means going the other way, symmetrically, -1 should be it. So what it looks like to me is that standard deviation should be 2. Going back to the data, that is not what they got. They got 3. Oh, sorry. 3 is correct. That's exactly what I got. So yeah, this goes to 5, and 2 plus 3 is 5, and then -1. Okay, good. So I had that wrong. So a lot of you put 2 because you saw the 4 and you thought automatically, oh, it has to be 4. So it's 3. Okay. Next question. Number 3, this is a transformations question. So, what we have here, it says rainwater was collected with water collectors at 30 different sites near an industrial complex. The amount of acidity was measured. The mean and standard deviation were 4.6 and 1.1 respectively. When the pH meter was recalibrated at the laboratory, it was found to be in error. Turn down the music. Okay. The error can be corrected by adding 0.1 pH units to all the values, then multiplying the results by 1.2. Okay, so we have 2 transformations. 2. Back to back. Okay? Back to back. Which means we know that addition of this 0.1 is going to change the mean, but it doesn't change the standard deviation. Okay? So 4.6, when we add 0.1, transforms it into 4.7. Now we don't see 4.7 as an answer because we know that when we multiply by 1.2, it's also going to change the mean. So we're going to multiply this by 1.2. That gets us 5.64. So it could be, we know it's not D, we know it's not C or D there. So it's limited to A, B, or E. Now, what affects the standard deviation, this 1.1? Well, addition does not affect spread. Okay. However, multiplication does. So we need to take this standard deviation and multiply it by 1.2. We get 1.32. So that means B has to be the correct answer on this one. Looking at our results, we got that. 10 people had gotten it. All right, now let's look at the special request. 9, 10, 11, 12. So let's look at all of those. All right, number 9. Here it's talking about Z-scores. It said until the scale was changed in the 1995 SAT scores were based on a scale set many years ago. For math scores, the mean under the old scale. So I'm going to write some of this up here. And actually, hold on, before I do this, I know that, well, we'll get 10 in a second. So this is fun. We know that the mean is 470, and the standard deviation is 110. And then we have the other one. So the other mean is, this is 2009, the mean was 515. And the standard deviation was 116. All right, so now what we want to do, it says, what is the standardized score for a student who scored 500 on the old scale? So we're interested in this old scale here. This is the 90s here. So to get the z-score, it's z equals x minus mu over standard deviation. So that is, what is x? They scored a 500, so that's what goes there. Take away the mean, which was 470. Subtract 110. So this is what we want to do. I'm going to go ahead and pull up the calculator. 500 minus 470 divided by 110. So we get 0.27 repeating, but we're just going to go with E on this. And that's how you get that answer. Now, the next question, number 10, says Gina took the SAT in 94 and scored a 500, which we just calculated a score for 500. So we have her z-score. Her cousin took the SAT, it's a pretty big age difference there, in 2013 and scored a 530. Who did better on the exam? How can you tell? Well, let's go ahead and do another calculation with the new scale. We want x to equal 530. So then that means for our z-score, we want z over here, it's going to be equal to 530 minus 515 over 116. So let's see what her z-score is. So this one was 0.27. Calculate this one. 530, take away 515. So that's 15 divided by 116. So we get 0.129 or 13. I don't know how it would round it. So let's look at the question. We have our z-scores now. Who did better, Colleen or Gina? So Gina is the one, the older score, and we know that she did better. The z-score of 0.27 is greater than this, so she did better relative to her class, okay, comparing these two distributions. So Gina did better. Is that, yes, Gina. Yeah, Gina took that one. So Gina did better. Her standardized score is larger. So on this one, I believe it's going to have to be C, okay? C should be the right answer on this one, so let's double check that. Number 9. E, hold up. What did I... No, number 10 is C. Okay, good, we got C. Good. Now let's look at 11 and 12 to finish things up. Go ahead and... Okay, so it says, what is the probability that the random variable is greater than 3? We have a uniform distribution, so we're trying to go from 3... And we want this entire area to the right is what we want. We want all of this region here. Okay, that's what we want. So to do that, we know that the interval width is from 3 to 8. Remember, this technique only works on a uniform distribution, but I know that that's going to be a length of 5 right there, divided by the range, which is 8. So 0.625 should be the answer on this, so C. Then it wants the interval between 0.1 and 0.8. So 0.1 is way over here, and then 0.8 is down a little bit. So it's between these two green lines. But we're gonna do the exact same thing. We want the interval width, so from 0.8 to 0.1, so 0.8 minus 0.1 is 0.7. So that's the width between the green lines, and then we're just gonna divide that from the range. Divided by 8, So 0.0875, and I believe we're going to round that up to get our answer, which is B. So that's how you're supposed to answer a lot of these questions. There weren't many normal CDF calculations in this one, but I think you guys did a pretty good job overall for those that were able to participate in this. You're going to have your test instructions sent out best you can, okay? Because you guys are on top of the mountain, but you're really only halfway up. Think about it.